Okay, guys, good morning. Long weekends are never good. You forget more than what you should, right? As such, when you come out after a weekend, it takes some time. And today, with 6 hours, it's going to be tough. Anyway, you forget what we were doing. So I'll kind of refresh your memories. We had started working on methods, right? We said writing methods in a program or making it modular into modules is a positive way of programming. Why? One, because each method can do a job independently, right? So you're writing jobs independently. That way you're dividing a big problem into small problems. So that's the first thing. That doesn't mean you start dividing everything into methods. You have to think logically, what will I require? I need a method for input, I need a method for processing, I need a method for output. Those are the three ones that you can kind of think of. Then the processing may further take more work. So my processing was adding numbers, subtracting numbers, multiplying numbers, dividing, and so I kind of put them in different methods. So the main idea is to take a big problem and divide it into logically independent units where each unit is capable of doing, is capable of doing a job, right? And that's the whole idea. That's one. Two, once you have a method, you can invoke it as many times as you like. Right? That's another advantage. So you don't have to copy and paste your code over and over again where you need it. So necessarily you may say, oh, I don't need it. I only need it once. So why am I putting it in the method? But we are not thinking today. We are thinking years after, right? So you learn to program not for only today. You learn to program well so that in any situation you can kind of think logically. So the fundamental course gives you Java fundamentals, but also I'm trying to give you programming fundamentals, right? So therefore it is called programming fundamentals. So how should I program? What would be a good way of coding a program, right? And there are so many examples up there on the internet. Try to read them, try to criticize what you don't like in them, and try to take what you like in them, right? And you can always discuss it with me. Small or big, doesn't matter, because small steps will lead you to bigger steps. So last week we had started working on methods, and I had written a program called calculator in which the user was asked for two numbers, and I said, oh, I'm doing the same job, asking for a number, asking for a number. Why don't I put this in a method that will do this job for me? So it asks a number for me and then it returns it. So every method is capable of doing a few things. It can take input in its parameter list if required, or it may have an empty parameter list. It may return a value, that is, it returns an answer, or it may not return any value, right? Usually methods will not do printing of results. Now printing of a message or printing of greetings and all that is different. That's not, I mean, it's just you're putting everything in one. But usually methods will not do printing of results. It will return the result to you and say, here is the result. It's up to you, the user of the program or the user of the method, whatever you want to do with it. Okay, so that's why we usually have return. We don't have usually have system printed for results in a method. So you may find it maybe in small books that are really written for fundamentals, like just to learn. But in the long run, a method does not do any printing. And if you kind of think about it, you've used a scanner class and you use objects of it, and it has some methods, next float, next int, next line. And you use the string class, of which you haven't used many methods. But if you go to the Java API, you will see every method is returning something, right? It has a return type. So our aim will always be to say, do your job and give back the answer to whoever is calling you. Let the caller decide what I want to do, not the call. You do your job, right? So we had written a small calculator in which one was taking input, two each operation, addition, subtraction, multiplication, division, and remainder, I put into methods, and I told you how to call them. I'm still away from creating classes. but I'll do that once we come back from the reading. Or maybe for you guys, it may be next week also, right? Because the other section missed yesterday. So I want to start it at the same time, but really, I could start it early. Okay. So today we'll continue with another example. We'll again learn how to work with methods now. We're still doing structured programming. So I'm writing a Java application. I'm not defining a class yet. Right? I'm still writing an application. An application will always be recognized by having a main method. And anything that you write in the main method is what gets executed. Okay? That's what gets executed. Okay. Just double checking that I'm recording it, because some students from the Monday section wanted to kind of look at it afterwards. And we'll go further with it. So we had done a small for loop. I had started with a small for loop last week, but we couldn't finish it. So I'll do that finishing part today and then go on to write a new program today. Again, it will have methods. We will learn how to create methods. What do they mean? And we will also then go into deeper the if or the decision making statements, because there is another one. There is also a switch statement, which is also a decision making statement. And if time permits, we'll start with the iterative statements, but it will continue as time comes. Okay. So remember, 3 pillars of programming: sequencing of your code. So how are you writing your order of actions, right? So if you don't write them correctly in order, of course, things will not work properly. So you can say add the 2 numbers before asking for the 2 numbers, is what I mean. So the sequencing is important. 2 decision-making statements are available in all languages. For example, if. So if it is raining, carry an umbrella. If it is raining, carry an umbrella, else stay inside. So you may have a simple if, you may have an if else. And there are also switch statements where you can kind of make decisions. If this or this or this or this. And you have nested ifs also. So it's not that you can only make a decision. You can say if marks are greater than 90, then grade A. Else if they are between 80 and 90, it's a grade B. Else if it is between 70 and 80, the grade is C, and so on. So you can do nesting of ifs and elses to whatever level. There is no end to it, as long as you write them logically for the computer to understand. And then the 3rd pillar of programming is iterative statements. In your daily life, you need to do a job a number of times. So iterative statements are available. For is available. While is available. Do while is available. So again, we are just starting. We're kind of looking into it. And as we go on, our aim is to keep repeating and using more complicated iterative and decision-making statements. So if you remember or not, we did a very small if statement when we did our program on, not on the calculator, but before this, when we were adding numbers. I said, if number 1 is greater, you subtract the smaller number from the bigger number, and you always got a positive difference, right? So we did a small if else. So I've introduced it to you. I'll introduce the for again today. And then as we go on throughout the semester, once we starting classes, then we'll concentrate more on designing classes, but this logic will still remain. You can't forget it, right? These 3 pillars of programming don't change. So if you have them right, all you have to do is just structure them differently, right? Package them differently. So these 3 important structures: how do I write my actions and what is the sequence? And if need be, call methods as I go on. So it calls a method, returns, calls a method, returns, right? 2, how do I make decisions in my program? Because you do that in daily life. So when you have to do it in programs, you need some statement. And how do I write iterative statements? Again, you do it in your daily life. Remember, you have made computers to do what you used to do. So anything that you do in your daily life has to reflect back here. So therefore, all these syntax or statements are available in every programming language, with little bit here and there, where you can write your program in sequence, make decisions, and do a job a number of times. Okay. So once I finish what we had left at last week, just because we had very quickly looked at the for statement, I'll do that for you. Start a new program today, write a little more complicated if statement, simple and if, and compare it, then write a while loop if time permits. But in that long run, I don't want you to forget that writing in pseudocode and drawing flowcharts for beginners especially is a positive way of doing programming. So what is the pseudocode? Pseudocode is something that you will write in English. For example, suppose we just want to take two numbers and add, subtract, and multiply them. So if I was writing it in pseudocode, I would kind of put my thoughts on paper, right? So I'll say, okay, so input number 1. I don't even have to kind of define what their types are or anything. Some programmers do, but some programmers will just kind of write it in sequence, okay? Input my second number. And again, here there is no rules of syntax. You can call them number 1 or just like normal. It's just English, but you're putting your thoughts on paper, right? Add the two numbers and print the result. Right? And then you would say subtract the two numbers. You were taking the positive difference in that small example. I mean, I'm not even defining my methods. I'm just writing the pseudocode. Now, if this was my main program, I would write it here. If I needed a method, I would write it pseudocode like separately. Pseudocode for method 1, pseudocode for method 2, and so on. But it's just English language, right? Find the positive difference. And I'm not saying how I'll do it. I'm just saying what will I do. Or if you don't want to print the result here, we can say print all results at the end, like we will do. Right? Then your next step was find the product. Your next step was find the, and again, if you want to kind of say add the two numbers and you want to say in sum, you can say in sum. Find the positive difference in difference. So you're again mentioning your variables, but necessarily that's not what they're called, but they're giving you an idea of, oh, like what they are. So some programmers will say input number 1 float, input number 2 float, and they'll start telling you the types of the variables also, but it's up to you. Find the product in product or save in product or whatever, right? Find the quotient and save in quotient. And you're not saying what am I using, what arithmetic operator, and you're just writing it in English. Find the remainder after dividing number 1. But be consistent. If you call it number 1 here, call it number 1 here. By number 2. Then your next step was 8. Print the numbers. So print number 1, comma number 2, comma sum, comma difference, comma quotient. Oh, forgot something. Product. Quotient and remainder. So that's your pseudocode, right? So some students who are new to programming, and I would highly recommend it, you can start writing pseudocode before you want to write Java, because Java you may find it overwhelming just because it has syntax and all those things. But if you put your thoughts on paper in kind of English, then you'll say, oh, that's what I want to do. And then you can start kind of converting it one by one into its direct language. So what is this? So if I wanted to convert it into Java, I would say float number 1. If I wanted to convert that, that would be float number 2. Right? Add the two numbers and put it in sum. That would be sum is equal to number 1 plus number 2. So then it helps you to convert it into Java. Okay. So writing pseudocode is highly recommended, especially for beginner programmers. So if you would like it, good. If you can do it in your head, good. But you should know how to write it. So you can be expected to write it in an assignment, right? If it was modular, here instead of saying add the two numbers and whatever, I would have said call add method. And then the add method I would have written here. And I would write the steps again. I would say add the two numbers. And I'm again not talking about parameters or whatever. I'm just kind of writing it in English. And return the sum. So I would write the add method, the subtract method, so on and separately if required. Okay. So that's pseudocode. So very quickly, we stop writing pseudocode because we become better programmers. But that's your first step, putting your thoughts in sequence so that you know that's what I need to do. And another option of, though I mean I prefer pseudocode because the other one is more work. You can use symbols, and this is called flowchart, right? So you're trying again to show the flow of your program. And again, they have symbols. For example, if you want to say input number 1, the input symbol is this. And these are called connectors. So they're telling you, oh, from here I'll move here. You want to input number 2, you'll say input number 2. Now you want to do a processing. Processing is a square box. And again, you'll just copy it if you like, or in flowcharts, we kind of start writing more code. Though again, it's quite easy, but you can. And then after you want to calculate the difference. But in difference, I'm not going to say positive difference right now since we haven't learned it, but there is a decision to be made here, right? So before you want to make the difference, you want to calculate which number is greater. So I'm kind of making it here 1, and I'm putting a connector here 1. Now decision-making statement. Oh, I want to see which number is bigger. So you make a decision. This is a decision-making statement. It's a diamond, right? So I'm saying, is number 1 greater than number 2? If number 1 is greater than number 2, how do you calculate the difference? You say difference is equal to n1, n1 minus n2. So here you can say n1 is yes, true, right? And if it is less, false, then how do you calculate the difference? You say difference is equal to number 2 minus number 1. And then both of them go further and join back, and then you calculate 2, and your 2 is, oh my God, very quickly I run out of here. So 2, now you calculate the product. So product is equal to n1 into n2. And then you calculate the quotient, you calculate whatever, the remainder, and then printing. Printing again 4. See how very quickly I run out of space. And again in 4, you say print the result. So print is output. So you can put an output symbol, and then you say stop. So though very untidy, but that's a flowchart. It's giving you the flow of your logic. Right? Now you can make flowcharts by hand, no problem. Or if you like, and if you don't have it, you can look for some free one on Visio 2016, which is one of the, so here there are basic diagrams. You can draw flowcharts from here. You can choose a template if it works for you. Otherwise, you can always create one and see how symbols will appear here. So if I want to start, I'll put a start symbol here. So that's my start, right? It's kind of what it will be. And then you want to connect it to an input number. So the input number is data. Or the other way is, I'll show you. There are ways of doing it. You can kind of click on here and it shows you an arrow. What do you want to connect it with? You can click on the arrow and you can put the input symbol. So the arrow will be made itself. If you don't want to, you can always use a connector from here, right? So this is, and you say, how will I type inside it? Just start typing inside it. So what was it? Input number 1. Right? So that's your start symbol. Can I put something inside it? Yes, I can. So you can draw it by hand if you like, or you can just do it here. So again, if you use the diamond here and kind of go here, it will do it. You want to input number 2 now. Right? Now I want to do this, but I want to go to a processing here, right? So I've made processing. So what do you want to do here? You want to go sum. Oh. Sum is equal to number 1. And I'm not using, I'm just calling them number 1, number 2 with blanks or whatever, number 2, right? After the sum, you wanted to calculate the difference, but you wanted to make a decision. Okay, now here is your decision. So see here, this is a flow chart. And Visio is one way of drawing it. Instead, if you didn't want to draw it with hand. But again, there are other programs. I'm sure there are free programs on the web if you don't have Microsoft Visio. Just go draw flow charts and you'll have many of them. So now here is the decision. So what do you want to do? You have the 2 numbers. You're comparing the 2 numbers. Is number 1 greater than or equal, whatever you like, equal to number 2. Now it has changed the number n to capital because it's just English. It's kind of looking at English and do an enter. So now here you're saying, oh, if it is bigger, I want to do this processing. And if it is smaller, I want to do this processing. Oh, made the wrong one. And if it is bigger, I want to do this processing, right? You can start writing on arrows if I'm not mistaken. So is it greater than or equal to? Let's say true. Right? So is it true? Is number, oh, just because the n went there, sorry, but can't do much about it. Or maybe I can make it a little bigger. Who knows? Can I make it a little bigger? Of course, if I do it this way, it will, no, it hasn't. So it's kind of looking odd. Can I make the size? No, I can move it. So I'm sure I can. Oh, there it is. So you can kind of make it bigger if you like, and then make it much neater. I'm trying to put the n with it, but somehow I'm not very successful. You can move stuff once you've written it. It's not as if you can move it. Okay, so if number 1 is greater than number 2, so you could take still, it hasn't still given me. So this square bin is for moving, right? And for changing it's there, it's changing its size. No, it's still moving it. I don't know. I haven't done Visio for a while, but it's not as if it's not doable. Okay, so if it is true, so number 1 is greater than number 2. So what's your difference? Your difference, it's making D capital by as word does it, irritating, right? Number 1 is bigger and number 2 is smaller. And again, keep calling them the same number. If you've kind of put a blank there, put a blank here. And if it is the other way around, number 2 is bigger. So take your number 2 and subtract it from number 1. Right? Now, both of these have to be kind of connected to the same processing, to the next processing. So I'll draw this and I'll take a connector from here and I'll kind of say, oh, you also connect to the same thing. I can take this and, oh, no. Control Z. Your job is done. I can take, no, your job is also done. Don't want the connector anymore. I can take this and kind of move it here. So they'll kind of look like this. See, so I made a decision-making statement and then I did 2 processings. So all you have to do is you have to kind of read them as you go on. So we'll look at them again. So we said start. We said input number 1. That's the diagonal box. Okay, it's kind of already predefined that diagonal boxes will for input. And if you can't remember, see here how it says data. Data means input and output. Okay, then input number 2. Then here is processing. So processing sub-process. So now you could kind of like, or you can, instead of this, this would be more better if I was calling a method. This would be better if I was doing the processing here itself, which I should have done. So this is basically saying sub-process means call a method. Okay, but I didn't see that there was a process here. And then here, now what's your next job? Your next job is calculating the, after the difference, what did you calculate? The product. So go back, number 1 multiplied by, so you can start using symbols here, though you can again write it in English. It doesn't really matter, right? Now, what do you want to do? You want to kind of, again, connect it and find the quotient. So here, now I've chosen the right one. I should have chosen process. If there is no methods, I would have chosen the blue ones. And the sub-process is basically for method calling. Okay, that's what it is. But I mean, when you draw it, you can differentiate it. Okay, here, now we want to do the quotient. And you want to say number 1 divided by number 2. That's your quotient, right? Now, the next step you want to do is again do the processing and go with the remainder. And what is the remainder? You will start using symbols. I mean, now you're writing it for, it's more, as I said, it's not English-like, it's more with the language now. Okay, so now we want to do an output. Where are you, output? No, I don't see an output. And I can use a connector and I can connect it, right? So notice that's what That's what it is. Can I replace it with no, I'll just have to kind of remove it and put it back instead of sub-process. So if you like, shut off your connector, Control X, we'll take this, we'll delete it completely, we'll take a process, put it in between, and then put it back here. Right, so that's simple process. So I'm not using these because this is for a method. Sub-process means a method. I'll take a Control C because I don't want to give you anything wrong, okay? Or Control X. You can just delete it and then put another process here. Oh, I'll have to do more work here. Okay. I'll have to do more work here. Then again, Control X, delete it, put back another process here, and I'll have to kind of take this and move it here. Right, so things have to, oops. When you start making decisions, then it becomes a little problem. But anyway, it's not a big deal. Kind of leave it where it was. Right, so I was just, my mistake was I took a sub-process instead of process. And sub-process is mainly for method calling. So you can replace it afterwards. And then last, what do you want to do? You want to print or display. You can start using input and print statements. It's just writing it in English. But I'm still not saying println or system out println. I'm still not doing it. Okay, so what do you want to print? You want to print number 1, comma number 2, comma the sum, the difference, the product, the quotient, and they're all defined now, right? And the remainder. There, job done. Kind of looks odd, but there it is. And then, of course, my last process is stop. No, wrong one. Control Z. And then inside here, I want to say stop. There is a flowchart. That's what a flowchart looks like. With wrong things I have, but that's okay. Now here, if you wanted to write something on the connector, we'd say false. That's how I've written the true and the false. So what is it saying? What happens if it is false and what happens if it is true? Now in that box, I had an extra line and therefore it kind of doesn't show the here. Right? So you can use Visio if you like. So I haven't changed this because this was more work, but that's a flowchart. So people will start with pseudocode because it's very English-like. And then we'll gradually move to flowcharts because flowcharts is using more symbols like multiplication, addition, modulus, and so on. But there are symbols and they all have a meaning. Like they're not very tough. So that's basically a decision. That's for process means anything you're doing. That's for start and end. That's for input and output. That's for calling a method. And there are more shapes. You can kind of go and search for more shapes. Right? If you wanted to do something for business or engineering, there are more. There are Visio extras here, annotations and callouts, the at ones when we will do, but if you don't require them right now. And if you wanted to do more stuff, there is more here. But for us, in a fundamental course, that's more than enough. Iteration, how is iterations showed? To do something a number of times, take out an arrow and bring it back. So kind of put it in a loop. I'll show you when I do iteration, right? That's a flowchart. So step number 1 is a pseudocode. When you become good in kind of writing pseudocodes, you can start doing flowcharts. But you should know what they are, what the symbols mean, and how can I draw it. You can draw it by hand. There is no problem with drawing by hand. But Visio is one where you can use it. And there is a third way of also representing your code, actually not in code, but like a diagram. And it is called UML diagram, Unified Modeling Language. You say language and you're saying it's a diagram. It was just called Unified Modeling Language, UML for short, but it also uses symbols. And I'll show them to you when I kind of do work today. Okay, so if I wanted to draw in UML, I just need different symbols. But it's an activity diagram. It shows you what actions you are taking and in what order you are taking. Same as a flowchart. What actions you are doing and in what order you are doing. right? So you have to be aware of all this because these questions can be asked and will be asked in the next assignment when you do one. I've almost marked your assignment, almost. I just have, I think, less than 10 to go, which I'm hoping to kind of finish by tomorrow. Okay. And anybody who has not shown me their work, their running code in class will not get marks for that rubric requirement. It already says so in rubric. And so please don't come back saying, oh, Anju, why do I have a 0 here? I mean, I needed to see it in class and it said so in rubric. So if you've missed it, again, I'm still giving you this chance because I haven't yet posted it. If you want today, anytime, come and show it to me so that I can put your name on the list. But that's it. That's the end of it. Hopefully by tomorrow, I'll finish marking it. Okay. So my mistake, I'll do this afterwards and not waste your time because it will take a little time. But all I have to do is I have to replace these sub-processes by these solid blue boxes, right? So I'll have to make the arrows and so on again. Okay. And again, if you want to kind of move stuff and move them, these arrows will automatically move. So you've connected it. So look at if says, is number 1 greater? Yes. So calculate difference that way. Otherwise, calculate difference this way. And after you've calculated the difference, you come back and calculate the product. So both of them are coming out. Look at the decision-making statement. It has 1 input, but it has 3 outputs. You'll say, why do I need 3? You may be saying something like this. N1 is equal to N2, N1 is greater than N2, N1 is less than N2. So you have 3 ways that you can make a decision. If you need 2 arrows to move out, like I've done, sure. If you need 3 of them, sure. You'll say, what if I need more? Then you'll have to take out an arrow and then further create another decision box and create an arrow. And create as many as you want. So you're basically nesting them. Okay. So as your programs become more complex, your flowcharts will also become more complex. But the aim is, the idea is that you should know how to write pseudocode and how to create a flowchart. And again, I leave it to you. When you submit something, you can do it by hand, you can do it by Visio, or you can look for anything. I think it's called Draw.io is another one that I found, which was not bad. Right. So Draw.io, I think it is called. If you look it up, I forget, but I think it was called Draw.io. So if you don't have this, there it is, right? Draw.io desktop. You can only search Draw.io if you like. I think it was called Draw.io. So there are templates. So I'm sure this was the one. Yep, that was another way of creating a flowchart. I'm sure, and it's a free download. Draw.io. See, notice so how they have. So here are UML diagrams. You can draw UML diagrams. You can draw flowcharts, and look at the complexity. As you write bigger programs, they change. And I'm sure it was. Oh, there is pricing, but I think it was a free download if you wanted it for just something, if I'm not mistaken. If I don't want pricing, if I only want a free download or something, I'm positive. Oh, here people also search for how to draw. So there are some more. But this was the one that I kind of, maybe because it was the first hit, how to draw flowcharts. That's what I saw. There is pricing. Let's see what's under pricing. Get free trial. I think the trial works for a month or something. And then once you use it, you're okay. Okay. So if you just have to do a job once, it's kind of okay. But I haven't used it, like in the sense that I didn't draw with it, but I was looking up. So all you do is you just kind of go flowchart software. Here. So there are many. So this is not free. I know this is not free, but here somewhere I found more. So look at it. There are so many. So look for a free one if you don't have Visio. So again, they say what is the best one? I don't know. So they've kind of done it. Lucid Chart, Microsoft Visio is not bad. It's at number 2. We used to use it for UML, so I know how it is. And then, of course, how can I create a flowchart? You can always do it by hand. Okay. Here it is, flowchart software free download. So here, there are some here. Okay, so you will be required to make it. If you don't have Visio, it's not that you have to do it by hand. You can choose whatever you like. All you have to know is these symbols, and they'll be present in all flowchart software. but you have to know which one to use. So input and output is kind of quadrilateral. The others are squares. Arrows are connectors, and start and stand are common ovals, right? Decision making is diamond, and iterative is just putting your arrow back. That's what iterative is. Go back, go back, go back, and do. So when the time comes, I'll show it to you. Okay, so you should be aware of it. Okay, so you should know how to work with it. So if you like, I'm going to save this and then make it clean and then put it on Blackboard for you if you like. So protect diagram, remove, reduce file size, check compatibility. I'll just do a save. I'm okay with it. Let's browse it. Let's go to courses, look for PF30, look for Tuesday. There you are. Create a week 6 folder so that I don't forget. Though it is not, it's the one for what we had done in week 1 actually. And let's say drawing. And notice how it is. Do you notice the extension VSDX, Visual Studio Diagram something, I think it's called. And I'll put it with, maybe I'll just put it with the program that we did, the first program that you did. Simple arithmetic one. I'm calling it simple arithmetic so that I can remember. And of course, it's a flow chart. I'll put a sample up so that you can see, oh, that's how it looks. After, of course, I correct it. After I correct it, I'll put it on Blackboard for you. Okay, so that's a flow chart. Nothing big in it. They're just a few symbols, but they're used to kind of put in a diagrammatic form a visual, and people love to see visual. What will be the flow of your diagram and what will be the flow of your program and your actions. So actions and flow together make a flow chart. And so do activity diagrams, which we'll refer to today. Okay, we'll refer to activity diagrams today. So pseudocode, just English like, flow charts using certain symbols, and activity diagrams, UML activity diagrams, again, just a kind of a chart, but the symbols are a little different. And I'll show you examples today. Okay. Okay, so let's get back to where we were before we forget. So when we left last week, I was showing you a for loop, a way of doing a job a certain number of times. And my aim was to show you how you can make a program run more than once. Right now, when you run your program, it only runs once, right? It does your job and it says, okay, I begin, I do this, and I finish. And exactly it will do, you've told it to do that. You haven't said, do this job 5 times or do till I say stop. So you can kind of fix it, do it 5 times, 10 times, 15 times. Of course, it will be a positive number. Or you can say, till I am tired of it, keep running. Right? So that's okay. For example, you will say, though it's silly, but you will say, drive my car for 10 kilometers. So you've made a decision. Or you will say, drive till I reach my destination. So that's the difference. So the for loop is usually used when you know how many times you have to do a job. And while loop or do while is used when you're kind of dependent upon a condition. So drive till you reach your college. So there is a condition, right? Though for can be done the same way, but for is more towards how many fixed number of times, and while is more based on why. So you don't know till when it will rain. So while it is raining, sit inside. Or you can make a decision. Wait for 1 hour and then go out. So that's the difference. Okay. So I showed you a for loop. The for loop has 3 parts to it, right? These 3 parts, as you see, we call them initialization, condition, and the increment and the decrement options. And I'll tell you what increment and decrement is, because you are incrementing the value of counter. And it has three of such. First one is called initialization, where you will usually initialize your counter variable. This counter variable is just saying, how many times do I want to start? Is it a rule you start counting from 1, 2, 3? No, you can do reverse counting if you like. 5, 4, 3, 2, 1. Or you can say, oh, I want to do this. I want to do even numbers, 2, 4, 6, 8, 10. Sure, whatever you like. So I can say, oh, write a for loop to print out the even numbers. You should be able to do it. You say, I want to start with 2, and then every time I want to increment by 2 and print it out, right? So for loop helps you in many things. Okay, and we'll learn how to do that. So here was a very small example, and why I took this example to start with, because I wanted to change my code in such a way that I could run my program more than once. Right now, I can only run it once. That's it, only once. So if I go here and I do a right click and I run it, so this application takes two numbers from the user and performs arithmetic operations on them. Operations performed: addition, subtraction, multiplication, and division. Finding spelling is wrong. It displays the number and the results of all operations, right? So please make it a point. I haven't docked marks this time, though I gave you my output and it's told you, showed the purpose at the beginning. This time I haven't. But your program should always give me an idea of what it is doing. Why? Because then if you ask a question of me, please input a number, I exactly know why are you asking me a number. Okay, so my first number is 12 and my second number is 4.5, just for the heck of it, and there is my output. Right, so there's the number 1, number 2, sum, difference, product, quotient, remainder. Seems like we didn't do any kind of formatting here, we just printed it out, so I don't see any formatting with 2 places after decimal or so. The precision is 6, 10 to the power of -6. Right, so how do I know it is -6? Look at 1, 2, 3, 4, 5, 6 places after decimal, so 10 to the power of -6. So now you can say, oh, the precision is -6 for floating point numbers in Java. Now that you know precision in math. We talked about precision in math with your section. Have I talked about it? Do you remember from last week about precision when we were talking significant digits, accuracy, and precision?
I remember.
Good, thank you, Kiran. Right, so I did talk about it. So that's what precision is. So it's only working once and then it's done. I can't run it again. And it kind of becomes irritating if you want to kind of keep checking. You'll say, oh, I have done a 12 and a 4.5. I want to do a -1 and a 4. I want to do negative and negative. So you just want to kind of check that it works for everything. And it's not so difficult, but every time you'll have to go options, clear, go back to this window, or go to your command line, run it again, and so on. So a better way would be if I could make it say, oh, run for 5 times. So we've already learned how to make it run for more than once. And this simple loop is doing this. It takes a variable called counter. You can declare it IJKABC. That's the only place in Java where you can use names that are not meaningful, because they're called loop variables. Okay, and the practice is to declare them right there. Notice how I've said int counter. Though there is nothing that stops me, I could have taken this int and I could have just put it here with my other declarations. But it's just a programming practice and everybody follows it. Okay, so it's not wrong to declare it with other local variables. Like some of you declare your variables where you need them. You put them right. You say float number 1, float number 2. Again, that's not a usual practice. The usual practice is to put it right here. All of the variables together. But again, it's your personal preference. I can only tell you good programming practices. Whether you follow it or not, at the end of the day, depends upon you, right? So even in that small program that you wrote for your assignment 1, where we had maybe how many, I don't know, 2 numbers were taken and it was calculating the three inputs and just a display. Some students have declared variables right where they need them. There's nothing wrong in it. It's just not the programming practice. So the practice is declare your variable here and give it an initial value. You could have done it like this too. You could have said it here. But again, it's not something that is done. You could have taken it outside and put it here. And then removed it from here. You could have removed it from here, and leave that part empty. Doesn't look too neat. And doesn't look too, self-explanatory. So I could do it this way. Nothing stops me. So I did my initialization before the for loop. But when there is a place to do the initialization, why don't I do it where I need? You'll say, what if I want to do more than one initialization? No problem. Put a comma here, put your second variable here and initialize it right here. So you can initialize any number of variables you like in the first part. You may need 2 variables to begin with, 3, 4, whatever. So that's your initialization part. As many number of variables can all be initialized, separated by commas. Type name equal to value. Type name equal to value. So before the percentage, any number of initializations that are required for the for loop. And so that you know, this counter variable, just so that you know, this counter variable is local to for. I can't use it anywhere else. I can only use it in for. So after the for loop, if you wanted to print the value of counter here, it would bark. It would say, I don't know what counter is. So that's another thing. You're saying, I just need it for the for loop. Why do I declare it in my method where everybody can use it? So that's one way of looking at it. But that counter is only local inside for. You can only use it inside the for statement, nowhere else. You'll say, oh, well, I don't like the idea. Sure, declare it outside. Okay, so depending upon its use, you don't want to declare it over and over again in your program. You're using 10 for loops. Just declare it once and use it as many times as you like. Which reminds me, if you need a scanner object to read something, you only have to use one scanner object. It doesn't depend upon how many numbers you are reading. You declare a object, and this a object will help you to read thousands of values. Doesn't matter. You just need an object. So when I say, if I need a chalk, I'm writing something on the blackboard, I need a chalk. I just need a chalk. Every time I need to write a new line, I don't change my chalks. You see? So I just saw it in a couple of assignments. Scanner 1, scanner input 1, scanner input 2, scanner input 3. One to read the first number program name, one to read the student number, one to read the tuition fee. It's not wrong, but it's not correct. So it will work, but you are unnecessarily creating objects that are not even needed. And remember, memory is scarce, right? So one scanner object, all you're doing is you're creating a object capable of taking input from the user. And you can use it as many number of times as you like. So keep that in mind, okay? One scanner object. If more are required, then it would be, oh, I'm reading it from the keyboard, I need a different one. I'm reading it from a file, I need another object. So if you're connecting it to different input devices, then it makes sense. But if you just need to connect it to the keyboard, I have it. Use it, right? Use it. Okay, so just because it came to my mind. Okay, so is everybody clear with this for loop? Okay, so this is how it works. Starts initialization. So steps are this. Initialize. That's step number 1. Okay, then check the condition. That's step number 2. If the condition is true, execute the for body. It's called the for body. The body means whatever is in opening and closing braces. So you can put steps if you like. So step number 1 is initialize. Step number 2 is check the condition. And again, if you want to put it in block comments and it makes sense, sure, here. Here. Okay, so those are the steps that happen in a for, so that you don't forget. And you'll get it. I mean, it's not a big thing. So you initialize. Step number 2. You check the condition. And step number 3. If the condition is true, execute the for body. Else exit it. So basically, there is an else, right? Step number 4. So if you're still in the body, you're in the for body. So if the condition is true and you've gone inside the for, you will now do the third part, increment or decrement, whatever it does. The loop variable. If you want to call it loop variable so that it makes sense, you'll say initialize the loop variable. There could be more than one. But here you can, instead of increment and decrement, you can say manipulate. God knows what you want to do. You want to do a +2, -2, whatever. Yes.
So could you just write this entire for statement with a series of if statements?
Come again?
So if counter equals 1, system outprint counter plus counter, counter plus 1, if counter plus 2 continues.
Okay. Right. So Ben is asking, can I replace this for by if statements, a series of if statements? So I need 5. Sure, you can. But the for is so compact and you will need 5 ifs for it. So we go with it radial, right? But it can be done. It's not usually done, but it can be done. right? So you will say counter is 1. If counter is greater than 5, do this. Counter becomes counter plus 1. If it counter, so you will write maybe 15 lines of code to do something that I'm doing in 2 lines of code. But it can be done logically. It is not done because if we have an iterative statement to do the job, why would we write 5 if statements, right? But logically, it's the same thing. Yes, this is what the for is doing for you. So why would you do it? Okay. So increment, decrement the loop variable. And then you are basically go back to 2. Your next step is repeat the steps 2 to 4. Right? That's what you're basically doing. So this initialization will be done only once. Then it checks the condition. If the condition is true, it will go inside the loop body and execute it, right? Else it just exits out of the loop. Else exit the for loop if you like. If it makes more sense, right? Then you increment, decrement, whatever you've written in the third part or manipulate the loop variable. It's not always increment or decrement. It could be +2, for example. I'll show you examples of for loops. And then it says keep on repeating steps 2 to 4. So somewhere you will exit. Somewhere you will exit. Now, if you forget this condition, that becomes an infinite loop. It never stops. There is no condition. If I forget my condition or if I don't write it correctly, this is an infinite loop. So you have to be very careful. Have you initialized your variables? Have you written a logical, valid stopping condition? And are you incrementing or decrementing? If I forget this, it is still an infinite loop. Why? Counter becomes 1. Counter is always less than 5. So infinite loops can be written in the beginning, like when you're new to it. So be very careful. So any of these 3 can be left empty. Right? Any of these 3 can be left empty, but you are responsible to see that then there is other way. So I can leave the first one empty. I can initialize my counter outside the for. Good. Doesn't look too neat, but I can do it. I forget the condition, but somewhere in the for loop, I check the condition with an if statement, doing extra work, and I say, oh, if this condition is true, come out of the for loop. There is a way of doing it, though I keep away from it. There is a break statement that can break a loop. Not recommended. So why would I do that? When you have something that does a job efficiently and automatically for you, use that syntax. Right? Use that syntax. And I could, if I don't like it here, I can put that value right here. I can say counter becomes counter plus 1. Nothing stops me. I'm still incrementing counter, right? But the whole idea is to write a compact for statement. So if you know how to handle it, why will you try to dance about? Why will you write 5 or 10 lines of code when you exactly know this is where I want to start, this is when I want to stop, and every time this is what I want to do with my counter variable. So it's called the initialization, the stopping condition, which could be simple or it could be compound, which we haven't yet done, and then manipulating your counter, because counter is what is counting, right? This counter could be counter becomes counter plus 2. And I'll show you different things today when I do it. Just show you example. So is this for clear that it is printing out the value of counter for 5 times? It did. If you remember when I did it, when I worked with it. So I'll compile it because I made a change. I mean, I was doing stuff with it. So see, exactly, it worked for 5 times. It started with 1 and exactly worked for 5 times. Now, why am I showing you this? I'm showing you this so that now if you like, you have this option. So if I say, now run your program 5 times. I mean, you could say 10 times, 20 times. This doesn't matter. So what will you do? You already know this for. You'll put your for here. I mean, that's printing was just to show you, okay? So start your for here. And where should you end it? You want to do everything 10 times. And end it before the me. Here. For. And just to make it neat, I'm going to take all the code that's inside it, though it's not required. But remember, we human beings are nice if we can do things like this. And you go to edit and you say indent more. There. So indentation is something that, again, a programmer will always use. Just by default. Bad habits die hard. So don't get into bad habits. Create good habits from the beginning. Right? So what have I done here? You wanted to do it 10 times, change this value from 5 to 10. There. Now this, everything that is between the for body, counter will start from 1. You're using the same variable, doesn't matter. This finished here, dead. There is no counter outside this. You again chose to call it counter. You can choose to call it I, J, K, loop counter, index. These are common names. Okay. And then everything that you did before, the whole program, just before the closing of main, just before the closing of main. Remember, the other were methods here. If you had written this, just before the closing of main, I put the end of for. So everything in the main, I put it in a for loop. And I said, do it 10 times. Too much to do, but it will do it 10 times. So now the program will run 10 times. It should. That's what the for loop does. Let's try it. It can become irritating at times, but that's okay. Okay, so let's try. Compile it. Oh, why the machine is executing? Oh, the previous one is running. Okay, so to shut it, there is a, okay. Sometimes this happens. For whatever reason, you can kind of stop it right here if you want. There is a way of stopping it right here. Notice here. So I don't know why it was running, because maybe I didn't complete the previous run. You can just click on here and it will stop executing, or you can always go to the debugger. What is a debugger? It kind of shows you line by line. We haven't yet done debugging a lot, but you can also terminate it from here. So what is a debugger? Debugger is basically if you want to look what is happening in your code line by line. That's when you can kind of open the debugger and it will go on side by side. Right? So let's keep it open and see what happens. So let's compile it. Let me see if I can show you both of them together. And let's run it. Where are you, window? Here. Okay. Kind of too many windows, right? Let's see if it shows me what's happening in the debugger. Okay, so it says, please input a number. So let's give 12. And let's give 13. It's not showing me anything in thread is running, it says. Threads must be stop, it says, but oh, here, you have to step into and continue. So, okay, I'll do debugger some other day with you. I don't want to do too many things at the same time. Debugger just tells you, you can look at it step by step. Okay, so where were we? Here. Okay, so that's one call. Okay, I've run it once. Oh, it's asking again. See, I ran it once and it's asking again. Because I told it to ask again. So I give a -1 and I give a -2.5. Oh, it's asking again. It will do this 10 times. It will do it 10 times. Now division, it's floating point numbers, so we are okay. It says not a number for remainder and it says infinity. Remember, we've talked about this before. With floating point numbers, the Java programmers have taken care that if you are working with floating point numbers, they give you an answer and they don't terminate. The program doesn't terminate. Doesn't behave like this with integers. God knows why. And right, come again. Did you say something, Daniel? Okay, so try 5 and try 56. So you can keep on going. It will exactly work for 10 times. You don't even have to count. It will. And you can use floating point numbers. Nothing stops you. It's still not 10 times. So as I said, it does become a little irritating if we kind of do it for 10 times, but that's exactly what you're told to do there. 10 times 10. Now it has stopped. So you can make your program run as many number of times as you like using the for loop. Okay. So that's the for loop in its easiest use. Start counting, stop at a particular condition, and every time increment it up by 1. If you make a mistake in any of these 3 conditions, your for loop will not work. It won't. It will create problems. And to show you how it will create problems, let me show you right away. I forget to do this. I forget this, or I forget my stopping condition. I forget it. I just leave it empty. So you can't leave it empty and you still have to put the semicolons, okay? You leave it empty. So it will compile, it says, that's okay. It's a logical error. It's not a oh, it doesn't like it at all. Good. Let's see, what does it say? But you can write an infinite loop. Unreachable statement. Okay, so it's saying I cannot reach this statement because, so BlueJ is doing it for you. It says, this will never finish. So it's a little smart. Again, ID is a little smart and it is telling you, logically, if I do it on the command line, I should know. It will still say it. So they've incorporated it in Java, I think. Do you want to try? I can try it. Does it happen on it should work. At least I should be able to show you that it is an infinite loop. Otherwise, what's the sense? Like, so week 6, we are in week, oh, that was in week 5. So I'm going to take this, Control C. I'm going to say if I get the same error on my command line also. But I'm sure since BlueJ is using Java at the back end, you'll get the same problem. Not the same problem, the same solution. So the IDEs are becoming smarter. I thought I copied from here. Maybe I didn't. Control C. Oh, we know we have to go one more, right? No, the calculator is sitting right here. And paste. Why isn't it pasting? Strange. Control C for copy. Come back here, do a Control V for pasting. Okay. Javac. It was called calculator tab. I have to say .java. It's still saying. It's saying, what is it saying? Unreachable statement. Same error. So Java has improved. Can't do much about it. I wanted to show you that it is an infinite loop, but it won't let me do it. It says you've forgotten something. And why is it saying unreachable? Look at the error. It's not saying it's infinite. It says, I will never reach this statement. You'll say, what does it mean? It means that I can never come out of this. That's why I can't reach the statement. That's what it is trying to tell you. You'll say, but why can't it come out of this? Because there is no stopping condition and it's an infinite loop. It will run forever. If it will run forever, it will never reach here. And that's why it's saying unreachable statement. So though the error is not very clear, but that's what it means. If you think about it, I cannot reach this statement. Why can't I reach it? Because this loop is infinite, right? So I'll put it back, Control Z, and then I'm okay. So unfortunately, I can't show you an infinite loop, but because it's smart enough to say, oh, you wrote something wrong. Okay. That's what happens. What if I say counter and remove this condition? I can double check. Maybe it's smart enough to see you forgot this. Who knows? Control S. Let's compile it. Okay. So here now, counter will always be 1, is always less than or equal to 5, and this should happen forever. So it's smart enough to see the condition is missing, but it's saying, oh, maybe you will increment your counter here somewhere. Now look what will happen. I can run it. There's nothing wrong in running, but it is running infinitely. Counter is stuck at 1. I never incremented it. So you told it to run. It's running. Is 1 less than 5? Yes. Is there any increment or decrement? No. Does the condition always hold true? Yes. So it runs forever. And very quickly, it will kind of run out of memory and it will stop on its own. But if you can, I mean, if it doesn't stop on its own, then you have to kind of just close it like this or do a Control C. Let's try. No. What else can I do? I can go back here. I don't see it here. I can go back here and I saw that blue thing going somewhere. Here, I can see it in the BlueJ methods. Why can't I see it? Oh, because I can't see the whole window. And you can do it here. Or as I said, you can go to View, show the debugger, and you can terminate. And then it terminates. All right. So if you mess up, then you're responsible for it. So at the end of the day, the computer is a dumb machine. It exactly does what you tell it to do. So you as a programmer have to write the correct code. It depends upon you. Okay. So having said that, I'll kind of wind up this program so that you can. This was the aim, to show you a for loop. Though there are many more ways of doing the for loop, and I'll do it, but I'll do it in a new program today. Okay. So this is completed. This is what I showed my other section. So I wanted to complete it. It just took more time with you because we did so many other things and I explained the loop to you, but that's okay. And I'll put this back on Blackboard for you, the revised version. Okay. Now let's start the new one today. Okay. So go. I'm hoping it's running. So we'll go project. We'll go new project. And again, week 6, so that I can remember where it is, though I'm putting it. I know where I'm putting it. And then let's do something like, I don't know, what will I end up with? Let's say grades. Let's see if I can do this with you. If I need to change it, I'll change its name. Okay, so this is what you will get. So create a new project, call it whatever you like, as long as you can remember it and look at its name afterwards and say, oh, this is what it contains, right? So I call it week 6 grades. Oh, the only thing is I think I put it at the wrong place. I didn't put it where I should put it. So, but that's okay. It has gone into week 6 grades. There it is. It hasn't gone into week 6, but it has gone into week 6 grades. So that's another advantage of BlueJ. It creates a folder for you, and whatever you create inside it will come here, which is fine. So I'll put your flow chart after I do it in the right place. Okay, let's start now. Let's create a new class. Names of classes should be good. 90% of you have called your class assignment 1 in assignment 1. Is it okay? Yeah, it's okay. Is it the best thing? No. You were doing some student information kind of stuff with it. So call it student information, right? So the name of the class, again, must reflect what the class does. So a couple of you have also called it A1. That's fine too. But again, same thing with variables. Call your variables program name, semester fee, student number instead of stunu, prog, pu. Would make sense to me, right? So naming variables, naming classes, naming methods is important. Add numbers should be called add numbers. I don't want you to call it AN and assume that Anju knows AN means add numbers, right? So the whole purpose of naming variables, methods, and classes, and of course our folders, is so that we can remember what we see 10 days from now or an year from now. That's the whole purpose, right? So assignment 1, most of you, and some of you added their name to it and so on and so forth. So I've kind of, again, I'm not talking marks for it, as long as the convention is okay, but I'm trying to give you ideas. So when you look at your rubric, please look at the rubric with an open mind. There is no criticism in what I'm doing. I'm trying to give healthy ideas, right? That's the aim. If you take it that way, you will learn. If you take it to be a negative way, it won't. For example, though it should, I don't think it came from this class, on Sunday at 11 p.m., before the math quiz had to close at 12, a student is writing me and saying, your questions are very vague. Now that's okay. So what is the question vague? The vague question he sent me is, how many numbers can you store in 8 bits? Now what's vague about it? It's a simple question. How many students in my class? So it's very clear that I'm saying how many numbers can be saved. I know a couple of you came and asked me. It was not clear to a number, but it's not vague. It's very clear. It says how many numbers can you store. I'm not saying what's the smallest number you can store. I'm not saying what's the highest number you can store. I'm saying how many. How else would I write my question? At Sunday at 11, it's just that I was up. I don't have to answer him. It's 11, it's Sunday. He's doing it 1 hour before the quiz is to close. So he's stressed. But he kept emailing me back and forth saying it was my mistake and he was not stressed and blah, 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 blah. And that's rude. That's not how you talk to anybody. I wouldn't talk to you like that. I'll take your ideas. If I like them, I'll say, oh, good. But if I see there is a scope of improvement, I'll say, why don't you try this? The whole idea of creating and giving back my comments is not to criticize you. The whole idea is you learn from it if you like and use it again. If you don't, that's okay by me. In the long run, you will learn it someday. If you don't follow conventions of naming your variables, that's perfectly fine. I'll keep talking of marks every time in the rubric. That's all I can do, right? So it was really tough, but I've done it for the first time. I had 90 kind of submissions or 80 submissions maybe. And in every rubric, I've given my feedback over and over again of whatever. But then I got so tired of doing it. What I've done is I've also put my solution on Blackboard. So you will see the solution of assignment 1 on Blackboard. I'll tell you that it's there when I put up and I say, now you can compare and see where I went wrong. So that way you say, oh, this is what she was expecting. I could have done it this way. If you like the idea, good. If you don't like the idea, don't take it. But I'm not criticizing anybody, right? I am not the Lord. I'm learning day by day myself. Everybody learns. And sometimes I learn from my students, and that's so good. I say, oh, that's a clean idea. Because your brain works different from mine. Right? So please be respectful when you write emails to me. And I'm not saying that one of you did it. I'm not saying anything, but I'm just giving you an example. Please be respectful to me and I'll be respectful to you. Otherwise, all I'll do is I won't answer. And I'm not supposed to answer at 11 on Sunday just because you don't understand a question. You had 10 days to look at those questions. Right? So it's not good. It's not respectful. So forgetting names is not the thing. I forget names, but that doesn't mean I'm not being disrespectful. I just am old. Okay, I can never put names with faces. I don't know. I never knew it till I started teaching here at Georgian. In Delhi University, I had a small class of 30 students. So I could always remember their names. Always, right? It never happened. But as soon as I came to this college and I started teaching 5 sections with hundreds of students, I lost it. I couldn't put names together. I'm still getting better here because I'm teaching the same sections. So you are in math and you are in Java, so I'm not that bad. I've started connecting names. I know some names. That's not being disrespectful, but not saying hello, Anju, or not saying thanks, or saying, oh, your questions are vague. That's disrespectful. Okay? So don't do that. It's not good, not only to me. You won't get any jobs out there. Your letter, your resume counts. What you say, how you say it counts. And respect is something that you should always show everybody. Doesn't matter age or gender or whatever. Right? Okay, anyway, coming back to it. So again, I'm not sure at the end of the day where I'll land up to, but I'm calling my class grades. Because what I have in my mind today is what I'm going to do is working with grades. Something like a nested if statement. Okay, so I've called it grades. So you can call it grade if you like. You can call it calculate grade if you like. So you can say grade, giving grades, whatever. I mean, it's something that will kind of come to you. A class is doing something. So therefore, you usually kind of give it a name that will make sense. String class is called string, so you know what it is. Scanner scans your input. So it kind of helps you to understand. So here I could have called it calculate grades, or I'm just calling it grades, or I could call it something that makes sense. Okay, so let's start. So again, we have learned how to write Java doc comments, and Java doc comments create Java documentation. It's not for only you and me who read each other's programs. It's for anybody who will need my class, right? So this program, and if your inputs are small means 1 or 2 or 3, then kind of just say what input you're taking. Take input from user and display it. There are 4 marks for commenting. What input are you taking? So the program inputs students or takes or whatever you would like to write. Be complete, right? It's like writing a purpose, something that I'll see and say, oh, this is what it does. So this program takes a student marks or mark, you can say, it's not marks, you can do mark, and assigns a grade to this student. And of course, it displays the result. Again, you can ask for the student number, you can ask for the grade, and so on and whatever. And as I improve it or whatever I keep doing, I'll keep adding. So that's the purpose. That's a complete purpose. Take input and display it. Doesn't make sense. How helpful is that purpose to me? Nothing. I can't figure out what you're trying to say. Display all inputted information. Doesn't help me a lot. Right? So commenting is something that will always carry marks in my assignments. And I want you to go out of this class with commenting coming naturally to you, that you will just comment your code. Okay, that's the reason. And of course, this is easy. And the version number, again, I leave it to you. You can put a date if you like. You can put a version number if you like, whatever is comfortable to you. Oops, though 19 is not far off. Okay, now I'm going to take all this and remove it. Leave the skeleton. Start writing my methods, and I usually always start with my public static void main method. So public static void main takes any number of string arguments, and you can call it whatever you like. Arguments is a good name. I would have called it arguments if I like, instead of args. Args is commonly is what it is written, but you can write the whole word arguments if you like. Start, end, and say of main. Right? So now your job, it says ask for a student number, a mark, and then assigns a grade to the student. So you have to take two input, you have to calculate the grade, and then you have to display the information. So kind of think about it, the tasks to be done. Ask for a student number, ask for the student mark, assign calculation, assign a grade to it, and display the results. So 4 logical units. So calls to 4 methods, right? Calls to 4 methods. So we've kind of said before we do anything, we will always display the purpose of the program. And we've kind of said, you know what, since we are writing methods, notice name of methods also follow camel case naming convention, same as variable. And again, I write these comments to kind of remind you when you do your assignment, you don't have to write it for me, okay? Not these kind of comments. Camel case naming convention to name methods, not these kind of comments. I'm not looking for these kind of comments from you. I'm looking for the functionality of your code. Keep in mind, she wants me to code to tell me what am I doing, not what next line does, not what next float does. I already know what that is. Those are coming from the library. I want to know what you are doing. So if you're saying, please input number 1, please comment it. Prompt for number 1. If you're taking it from the input, take input for number 1. That's what I want, right? So again, I'll as soon as I finish marking, or if you like, solution is already there in your assignment section. Go and look at how code needs to be commented for your next assignment. So your next assignment, when I get time, and I will, making assignments is not an easy job, but I will, and you will have something before the reading week so that you have something to do in the reading week, okay? So as soon as I finish this work with my next week's class, you will have a second assignment, okay? And it will not be worth 5%, it will be somewhere 15%. So it will be more work. So you'll have the reading week to take your time. That will give you a kind of practice also, to practice for your midterm that will come after your reading week. So you should be good. Okay. Okay. So display purpose, we will say whatever display purpose is afterwards. Okay. Now what do we need? We want to read the student number. So somewhere I'll be asking for the student number from the user. And again, I'll call it get student number. I'll write a method. By this time, I should know I don't need to pass it any parameters. But as soon as I need a variable, I'll kind of start declaring them here. So student number will take student number to be a string. It will give you these errors. The red squigglies are saying, what is it? We haven't written them, but I'm kind of writing my logic, what's in my head. Okay. So after you get the student number, what's your next job? You want to read the mark of the student, right? And And don't be lazy. Like, names make sense. Yes.
Student number is just string of numbers, not characters.
But it could be, you could be called GC123. So usually phone numbers, identification numbers, though they are numbers, they're usually taken to be strings because you usually don't do any math with it, right? And strings are easier to manipulate. Numbers are difficult to work with. You don't want to do any math with it, so just strings is okay. So if Georgian College changes its mind from today to tomorrow that our student numbers will not be just digits, but we'll put a GCB in front of it for Georgian College Berry, then I don't have to make any change. Similarly with phone numbers, right? Phone numbers are digits, we know that. But what if you want to put brackets or dashes in between? And the big advantage is with strings, you have so many methods. Suppose I want to extract the area code, the first 3 digits out of your phone number. If it was an integer, I would have to do math with it. And that's not easy. But now string has a method, extract the first 3 and it will do it for me. Right? So though a student number, because you are used to it, your numbers look like integers, big integers, and I made you do it as an integer in assignment 1 because I was doing a string, an int, and a float. That was my aim. But when you think for a type of a variable, and I've always said think intelligently, right? Why do an integer? Why? Because in an integer, then there will be validation. The user says ABC, blow up. Then you'll have to do validation with it. With strings, I can kind of reduce that. And I don't want to do any math with it. Similarly with phone numbers. Phone numbers are usually never stored as integers. Look at their size, 10 digits. And int will also not do. You'll have to use a long for it. And I don't want to do any math with it. What I may be more interested in doing with the phone number is maybe extracting its area code. Do you live in Berry? And those methods are available in string class. You can do so many things with string. You can find the length of your string. You can see how many times A occurs in it. You can find the first position of A. There are a lot of methods you can do with the strings. You can extract the first 3 digits. You can extract the last 4 digits. You can extract the middle. You can do so many, left, right, mid. Change everything to uppercase. Change everything to lowercase. So when there are so many things that have already been done for strings and it's already there, why would I use it as an integer? Because I'll never do math with it. So make those numbers as ints or floats or doubles or shorts or bytes that you know will be required in mathematical computations in your code. Otherwise, let them be strings. Easier. Okay. So I chose the student number to be a string because I'm not only looking to you. I have no clue. It's just an identification number. It could be a string. And 1, 2, 3, 4 is a valid string. Right? Even if it was digits, it is a valid string. Okay. Okay. So I'll get the student mark. And notice how I've started calling my methods get. Makes more sense. Get it. And what should be the student mark? Now you make a decision. We will make a decision. If I say, oh, the student mark is only an integer, we'll have to make it an int. Or if you have marks that I give you in your math assignments, 2.5, 2.66, 2.65, then it's a float, right? So it could be either way. But if the mark, usually this is what happens at the end of the day. This is what happens at our college, but it could be different. So we take your marks, we calculate the average, then we round it up. So if it is 22 point, like the final, we don't round it up every time. We are not giving you that every time. But when everything is done in the semester and we calculate the total and everything, and if your total is, for example, 78.6%, we round it to 79. If it is a 78.2, we truncate it to 70. So the final mark usually is an integer. But marks in your assignments can be floats, right? So I'm talking about a final mark because I'm giving a grade to the student, so I can keep it integer if I like. But there's nothing which stops you to make it a float. Okay, so I'll go with an int, and this is your mark. You can call it student final mark. So here, program takes a student number and final mark, if you like, and assigns a grade to the student. Okay, here instead of calling it student mark, you can call it student final mark, or if it makes sense, that's perfectly fine too. If there were more than one word, that's how you do it. You just kind of, every word except the first one is capitalized. And notice, by reading the code, you know what I'm doing. And that's very important. Some programs, I didn't even run them. I looked at the code and I knew they would be fine. Because they were so neat and clean and well written. Though I don't do that, I always run, because sometimes the display, you say, oh, it's okay, and something is missing. And that's why it takes me time to mark Java assignments. I have to take the code, run it, execute it, see that it works, and then fill up the rubric, and then give you marks. Right? So that's why it's taking time. Thank you for your patience, but it will come back by tomorrow or day after. The whole weekend I was marking it, like I had to. Otherwise, I would never complete it. I can never with working in school. Okay, so get the student number and then get the final mark. And guys, please be grammatically correct too. No spelling mistakes, should make sense. Get input, get input, get input. What input? Or just take input user once, and then there are 6 lines that do nothing for me. Right, so then I'm saying, what do you mean by a well-documented code? So maybe 10 lines of code in assignment 1 and 10 lines of comments. But that's okay. You're learning, so be your boss. But don't tell me what does next line do or what does next float do, or I'm making my output pretty. I'm not interested in that. Or 0.2F is used to put 2 places after decimal. I'm not interested in that. I'm interested in your comments. Right? So the first one says, get the student number, get the student's final mark. Good enough. Right? And then we now have to assign a grade. Oops. So I'm going to call another method. You can call it student grade if you like. You can just call it grade if you like. Whatever makes sense, as long as it makes sense. And we are going to use a new type today, which will be of character. Why? A, B, C, D, E, F, for example. Those are characters. I could make it string. Nothing stops me from making it a string. But it's a character, A, B, C, D, E. So why not use a different type so that you don't forget your types? Okay. And grade is going to be assigned a value. And I'm going to say calculate grade. So I'm going to call a method. But what will it require from me? So look at it. I'm just writing it as if somebody else is doing my job. So get student number is doing a job. Will return the student number. I know it will return it. I save it here. The get final mark, if you like, let's do it. I'm going to pass the student number to it, and you will see how I'll use it. I'll pass the student number written, and then I'll make it more personal. Ben, please enter your final mark. So I'm making it more personal. Instead of saying, please enter your mark, it will say, Ben, please enter your mark. So it becomes more personal, right? So what did I do? I took the student number from here, and I passed it as an input to the second method. You will say, but student number is not required to get the mark. Why not? I may have a list and I'm matching, oh, student number mark. And that's what we do in Blackboard. I look at the student number, I look at the mark, and that's how I enter it in Banner. So it would be nice to see this in the message, please enter marks for student number this. So it's easy. You can ask the name and say name, whatever, right? But I'm showing you. And then when you calculate the grade, what do you want? How will you calculate the grade? The grade is dependent upon what? The final mark. So you will take the final mark from here and pass it as a parameter or as an argument. Here we call them arguments. You're passing arguments to the methods. When you declare the method or you define the method, there we call it parameters. So you pass the grade. How will I calculate the grade if I don't know the mark? So I give the mark to you and you tell me the grade. So notice I'm kind of just writing my code, assuming there is somebody who will get the number for me. There is somebody who will get the mark for me. And there is somebody who will calculate the grade for me. And then all I have to do at the end of the day is display the student information. You can write it like this. If it's quite a big, there are 10 variables, or you can say display the student number, mark, and grade. But actually, I'm not doing it here. I'm just calling a method that does it. So that description will come there, right? So I'm not doing the work here. But I'm saying get the student number, get the student's final mark, assign a grade to the student, and so on, and display the student information. And I'm going to call a method. I'm going to say display results. I can say display student information, because it's not only the results, it's more than that. And this method will take the student number, will take the final mark. Then it doesn't matter how you pass it, but what needs to be passed? The number, the mark, and the grade you just calculated. The sequence is important in how you're calling it, one-to-one in how you write it. Otherwise, it's not important. You can change your mind and say, oh, I'll pass the mark, the grade, and the number. That's okay. And that's the end of it. So notice how my main has become neat and clean and small and compact. But now the job is to write each of the methods. So that should be your aim. Your aim should be, as soon as you get a problem, divide it into small parts. Logically correct small parts. So what are logically correct? You want to get the number of the student, or you can call it student ID. You can call it whatever, but don't call it student ID number. Kind of confuses it, right? Just don't call it ID, because it doesn't make a lot of sense. Then you will ask for the mark. Then the calculation has to be done. So if you kind of think of it, input, processing, output. That's all about the program. That's what a program is. Take input, process it, show output. At the end of the day, what is a program? Take input, process it, and output. And that's done. That's the end of my main. Yeah, the program will only run once for now, but that's okay. I'll tell you to, I'll show you different things as I go on. So slow and steady. We'll take a break. Okay, we'll take a break. We'll save this and we'll come back and start writing our methods. Okay.
Yeah, 67.
Can I ask you for a favor? We have a maths test. Math test.
Yeah. The quiz, not a test, a quiz. Yeah.
I'm not feeling well right now. Suppose we can write it someday.
You will have to write it with the class. There is one class tomorrow at 2. And check my syllabus. And then there is one class on Thursday at 11. You can come to either of those classes to write it. The problem is, it's just not the test. We are learning new stuff, and your section is doing something that the others have already done.
Okay, for learning, I have with my friend Edwin. Yeah, he's so
Okay. So you can take the test tomorrow or Thursday with any of the sections if it works for you.
Can I do it on Thursday?
Sure. 11. Check up my room number on my syllabus. Okay.
Can I give you?
Sure. If you have to. Name. To show that run? To show the run of the program?
I wasn't here last week.
Anything.
Because I was in the hospital. Anyway, the quizzes.
Oh, in the math.
Yeah.
Tuesday section did do something. Polynomials and 1.12, I think. Okay, so I know things can happen urgent. Out of the blue, you may have to go to the hospital. So it may have happened and therefore you didn't inform me. Right? So what you can do is, since I'm assuming you're not lying, you can take those quizzes from me today, do them and come back. Okay? So after class, you can come and take them if you like. Or just send me an email and remind me so that I get them to class when I see. Okay? Are you okay now? Well? Okay.
May I ask a question?
Sure, Kirit.
Can we use calculators during the quiz?
Today, no.
Okay.
Because those quizzes are just small things that you've done in quiz one. Remember the quiz one you did?
Yep.
Did you need a calculator to do anything there? Yeah, you don't. So you won't.
Okay.
Okay? Was the Java?
Oh, sorry. Yeah, sorry.
Are you in the right directory?
I had to change. I already. Oh, you want me to do it?
Whatever, as long as I know you can run the Java.
Yeah, I'll just do everything.
And what's your name?
It's Owen.
Owen?
So what time do we have to be back?
We started at 9:30, so 20 minutes. 10 to. Where did I put your names now? See, that's what happens. I forget. Oh, command prompt here. Owen, O-W-E-N?
Yep.
Last name?
World.
W?
So W, yeah.
Okay.
Okay. So. Oh, sorry.
Are you here to show me too?
Yes.
Where were you last week?
I was sick.
Okay, open up the command prompt, do it.
Yeah.
Okay. Okay, and just because you're showing it, we don't need a
Okay.
period here, right?
Yeah.
And if you're asking in the next line, then we don't even need the colon here. But I would recommend that since you've used these dashes to show your just the main thing, I wouldn't put dashes everywhere. Then everything has the same importance, right? So if you're using dashes to show a heading, don't use it in your comments.
Okay.
You see, then it makes no difference.
Yeah.
And then again, this is not a kind of a sentence or an exclamation. We don't use exclamation because we just small things, but just so that. So now I thought, oh, that was the explanation because they looked alike. They both had dashes.
Okay.
Okay, good. That's fine. I have your name noted.
Okay.
Okay. Honey. Sorry. Give me a minute. Your name?
Joel.
Joel.
Yes. Joel.
Last name Joel.
Bedard. BED.
Okay, thank you.
Okay.
So, yesterday I didn't have. I was just confused because the day I just heard that it was to the week 6 Tuesday, so I'm from class Monday.
Oh,
Yeah, so we didn't have class this week.
yeah. So if you don't have class this week, I'll do this stuff again with you next week.
Okay.
I have to. I mean, I can't do nothing. I mean,
No, because
Yeah.
there you said that, oh, but I have class Tuesday, so I can
yeah, sure. So if you don't want to come next Monday, it's up to you.
Oh, okay.
Because this
it's
is
the
what
same
we
thing.
almost. This section was a little behind. So the first half hour was given to that for loop, which you guys have already done.
Okay. Makes
So
sense.
yeah. So but at the end of the day, maybe they will be a little behind again. Now I know I have this extra class, so I won't rush. I'll do more stuff with them just because I know I have extra time.
Okay, no problem.
Okay?
Okay. Thank you.
You're welcome.
which is a question of polynomials. In the quiz, when we're asked to factor them,
Mhm.
we'll be asked to factor them completely or just to.
So when you're asked to factor them, when in a class quiz, I didn't give them space, so they were just writing the answer. But in an exam, you may have to factor each term separately, like I've done. Okay. This is not in today's quiz because polynomials were done afterwards. But yes, in the exam, I'll give you space, and you will know she needs to see each term.
Super easy. Yeah, I got a 72 out of 79 on the one networking team. It's hard because there's follow instructions. Lego. That's why I like the architect class. You get to play around with it. You just do it until it works. And then you don't really have to. Just on there, 3 left and right now. And then the third lead on the left. And I'm just waiting to apply it, see if anything actually works. Big files fine. That doesn't mean it won't work. Yeah, because I have factored in that long drive into the rest of the with the switch. It switches my controls to my screen. So I can reuse the 4 controls. Yeah, so I can use 4 controls each time. Yeah, the bigger RC controllers are really expensive, so you have to buy some. Do we have to go to? Yeah, we were just talking.
I don't know if we were on 6 or we were on
6.
I have a
Yes.
regular resume.
Yeah. I'll figure it out.
Yeah, I think what I'm going to do is I'll just find the resume that I have, changing and moving. You know, yeah. Yeah, I think we might have required working copies. We missed the date, I know that. I did a module. That might have been first. It was a first. Oh, rescue. Well, everything is possible to do on Sunday. Can you get some of that? Is that a test? Is that what you said? No, I switched it. So I have it. Yeah. This is what I was talking about earlier. The if statements being a counter. Oh, that's it. Give it 2 seconds. It's just. It's the same computer as ours.
Okay, now if that's what you were saying, this statement will only execute once.
Yeah?
A decision-making statement says, if this, do this. No.
Yeah?
That's not an iterative statement. This will do it once and this will do it 5 times.
So if I did this one, it would go, well, if the count is less than 5.
Yeah, so it will print counter's value and it will increment the counter to 2 and that's it. Then it won't go back.
It won't go.
No.
So then it'll run the entire code, then it'll come back up.
But which code? So after this it
if I
will
wrote-
go, yeah,
If I wrote more code after this, it would write this,
and then just go there.
go that. and then
If you wrote this statement 5 times, counter is less than equal to 5, counter is less than, then it would do the job of the for statement.
Okay.
But if you only write it once, it only does the job once. It makes a decision, yes, no, and that's finished. That's the main difference between decision-making statements and iterative statements.
So what I could do here is allow statement and I would keep it in this area.
Yeah,
here.
yeah, while or for, both of them.
Okay.
Yeah, so the same thing that you want to do here, you've written it here, right? So, but this and this are not equivalent. This will only do it once, so it takes the value of counter is 1. Yes. Is it less than 5? Yes. It will print out counter. It will increment the counter to 2 and it will stop. Then it goes finished. Job of if is done. Then it will come here and do what you want it to. Right? But if you wanted to get this effect from here, you will have to copy this code 5 times. But why would we do that? Right? Because we have the iterative statement.
I might need this sometimes.
Okay.
The student numbers is string, right?
Yes.
So like.
And you're copying me and you're still not following the right conventions. So what's the sense? All your variables, get number is not in the right convention. See, so what's the sense? I'm talking in class that follow the camel case naming convention and you're not doing it. Camel case says every word starts with the capital letter except the first one. And then you will lose your marks. And similarly in all your methods, all your method names are incorrect, convention-wise. So now why are you getting these red lines? Because we haven't yet written
No,
those
not
methods.
that. Student number is string, right?
Yeah.
So like when student number equal to get student numbers.
So this method will be called.
Copy into that one. Right?
This method will be called and the value it returns will go here. It's a method. The right hand side is a method call. Notice
So
opening and
we can give a equal to sign like that. It's not
It's
an
a sign.
integer, right? So can we do that?
okay, let's complete it and see what happens. Okay. Okay, guys, let's continue. I have errors in this code. I have errors in this code because I haven't yet completed it. It says I don't know what get student number is and so on, and that's fine, right? So if I compile it now, it's going to say, what are you talking about? What's display purpose? What's get student number? What's get student final mark? You haven't told me. And that's my job now, to tell what these methods are. Okay. So now let's start writing each one of them one by one. So it's not necessary to write it in sequence, but I'll do it so that it's easy. So the first method I'm going to write is this display purpose.
So pick this method from here. It's easy, then you don't make mistakes. Copy it here. Complete its signature. Remember we said all these methods will be private because they're only required inside the class. This method returns nothing. It's called display purpose and does a certain job. What job does it does? We'll write it here. This method displays the purpose of the application. That's what it does. Now, it's not necessary to put them in star, double star because it's a private method. You can just put it as a block comment, right? It can be just a block comment because remember, anything that is private, Java documentation makes no sense for private methods because nobody can see it. Java documentation only makes sense. It will only go in the manual if it is a public method. So because BlueJ is putting that, I mean, I'm just writing BlueJ comment so that you get into the habit of writing it, but it could be just have been a simple one. If you go to the documentation, when I do it, when it's all running, you will see that in the documentation here, none of the private methods will show up. And of course, none will show up because if something is private, you can't use it. So why do you need help on it? Okay. So writing Java doc comments for private methods is kind of useless. But it needs commenting, whatever you like, whether it's block commenting, whether it's line commenting. So I'm just using this so that you get in the habit. And I'll make it a little pretty here. So I'll kind of go system.out.println. And again, you can put stars if you like. I'm sure somewhere it should show me the column number. It would be nice if I can see the column number. You can copy this line and make a copy of it. And in between, you can write what I just copied from, which is gone now, of course. And we'll put it here. And to kind of stay in the same group, I'll say this program takes a student number and file number and consign grade to the student, and which has kind of come out very neatly. Just to kind of make it a little neater. There it is. There it is, and there it is, and there it is, and there it is. Now I don't need the periods here because it's not a sentence I'm writing, so you can remove your periods from there. There, done. So this is what display purpose does. It displays the purpose of the application. So when you run your code, that's the first method which is invoked or called. That will come on the screen. Makes sense? It says this program takes a student number and final mark. Now I don't need the and there because and assigns a grade to the student. So instead of you can say the now, just because we are kind of from the user or whatever. It takes a little while to make it neat, but job is done. Right? Purpose done. Display purpose is complete. Notice how I took the name. The name of a method also follow camel case convention. What is camel case convention is, guys, this. Every word starts with a capital letter except the first word. That starts with a small. That's what camel case convention is. I'm doing it right here in class and you're still copying me wrong. So definitely in assignments, you won't pay attention. and you will lose marks over and over and over again. So class names follow Pascal naming convention. What is Pascal naming convention? Every word starts with a capital letter. Every word, first, second, third, fourth, every word. What is camel case naming convention? Which variables follow and which also methods follow? The first word does not start with a capital letter. All other words start with a capital letter. So understand what camel case naming convention and what Pascal naming conventions are. Okay, so one job done. The second method to be written is this: get the student number. So it's a method, right? So take it from here, put it here, complete its comments. Again, it's a private method, so it's not as if I'll need the Java documentation. Now complete it. It's a private method and it's getting a student number and it will return it. So it returns a what? It returns a string. So that's its return type. And and don't forget static in front of it, guys. We'll get an error everywhere. Since main is static, it can only call static methods. That's a rule. Main is static in nature and main has to be static. You can't change it. Its signatures cannot be changed. And a static method can only call or invoke or talk to a static method. We'll come to static in maybe after the reading week. It will make more sense. And as you write these, kind of say of display purpose, so that you know what each one means. It's very handy. Believe me, it is. Okay, so what does this method do? Even if you are writing block comments, you will still have to write this. This method takes or inputs, bless you, the student number from the user. Okay, does it need any parameters? Do you see any params, any parameters here? No, it's an empty block, empty opening and closing, but it will return something. So what does it return? So using Java doc comments is kind of, it's easy to read. If it was in English, I would say this method inputs the student number from the user and returns it. That's what I would have written, and returns it. With Java documentation, I have to specially use add return the student number. And I again repeat, private methods do not need Java documentation because they are private. I'm just getting you into the habit of writing them just so that you know it. If it was normal commenting, I would have said from the user and returns it. That's all I would have said. I wouldn't have said add return. I'm just doing it. Okay, how do you now do it? Okay, so you are going to ask the user. So prompt for student number. Look at my comment. Okay, so how do you prompt? You put a system. I'm not sure how I reached there, but anyway, I got there, so I better come back here. Okay, so how do we go system? Dot out. Prompt means give a message, right? So don't say write a line of text. Doesn't make sense. All you say is prompt for student number. And you can say from the user. And depends upon you. You want to use print, you want to use println, whatever. It's up to you. Please input the student number. Now, let's not use words like you, me, your, and so on in a program. I don't know who's entering it. I don't know whether a student is entering it or a user, like a non-student, like a teacher is entering it. So don't say, please enter your student number. It may be me entering marks, right? So your, me, us, we don't use those pronouns here in programming because we don't know who the user is. So the user may not be the student. So please enter your student number doesn't make sense. So just say, please input the student number or please enter the student number, whatever you like, as long as it makes sense. A colon is good after a print just because then the answer comes right in front of it. Now in BlueJ, we can't see anything because we have to give our input at the bottom. But if it was running on a command line, notice after print, the cursor stays right in front. Okay, so you read it. Now what do you have to do? You have to basically, you can do a a local variable now because I want to keep the student number. So we'll declare a local variable here of what type? String. What would you like to call it? You can call it whatever you like. You can even call it student number. You can repeat the same name that you had there. You can go shorter and you can just call it number. Though it's kind of odd. I don't like to use incomplete names anywhere. But keep in mind, while I'm writing this method, I have no clue what and who is going to use me. I'm writing this method independently. So I declare a local variable student number. I ask for the student number. I say input the student number. That is a prompt and this is the input. And if you want to be a little more verbose, you can say and save it and store it. You don't have to kind of give, I mean, that's asking too much. And store it in student number and so on. But I mean, these are your starting programs, so you're okay. And we will need something else also. We will need a scanner. Anytime you have to read something, you will need a scanner. Now, if only the method needs it, put it inside the method. But if you need a global scanner, various methods are reading stuff, which I think it will in my case, I'll create a global scanner because then it's okay. Last time I said declaring global variables is a big no-no. But if an object has to be used, you use it, I use it, and everybody uses it, then it's okay to declare it as global. So the get student number is going to use a scanner, and the scanner is also to be used by the get mark. So I'm going to declare my scanner here outside the class. Outside, you can just do it here. It belongs to everybody. All methods can use it. Pick it up from Blackboard if you like. Pick it up from Blackboard. Which code did you lose?
Oh, today's code. My computer crashed on me again.
Okay, I'll put it on Blackboard. Don't worry. Okay.
All right.
It will go on Blackboard.
Fine.
Right now. Is that okay?
Yep.
I don't want you to be stressed about it. So under programming fundamentals, I'm putting it under week 6 so that you have the previous ones, though it's the same program. So this is how where your work is going. Okay, so I'm going to build, what do I build? Contents, items. So this is week 6. So we just finished one, which I kind of finished, and I'm going to browse it, and there you are, Tuesday section, and week 5 methods, and what was it called? Calculator.java there. It's on Blackboard for you.
Wait, was it called grades.java?
Huh?
Wait, wasn't it called grades.java?
Grades.java, I've just started writing it. You've lost this one also. Okay.
No, it's grades.java that I lost.
Oh, is this one you've lost? Okay.
Yeah. Sorry about that.
That's okay. So I'm going to put it like I'm going to attach it, but then when the time comes, I'll have to I'll replace it. Okay.
Okay.
So it's not yet complete. Of course, it's not complete. Okay, it's on Blackboard now under week 6 Tuesday, weekly learning. Okay, right now, notice something. I've declared these are called global variables. Main can use it. Get student number can use, or every method in the code can use it. Last time I was saying it's a big no-no. Don't declare variables, global variables, because anybody can change it. But look at the nature of this variable. It's just an object that helps you to read. You can change it. You know what I mean? Like it's like a pencil that we are passing around the class. Unless you really break it or change its color or do something to it, that's different. But it's just an object that everybody needs. So here it is okay to kind of declare it globally. Okay. Now, Java doesn't use this term global. In Java, we don't use the term global, but that's what it is generally. Any method can use this object. So I haven't put it inside any method body. Do you see it is inside any method body? No. Is it inside main? No. It's just sitting outside in the class definition. So it's basically a class variable. Okay. So instead of saying global, it's called a class variable. When I say class, any method can use it. It is available to be used in any of the methods. You will say, why did you do it? Because I need it in 2 methods. So I said, why should I declare it twice? Declare it, use it, die. Declare it, use it, die. Why should I do it? I need it in more than one method. It's something that never it's not, vulnerable. It's not as if it's a tax and a method changes it to 13, another method changes it to 15% and so on. It's just an object. So it's okay to declare it at the class level. So something new. Can you declare class variables? Sure, here. Now input can be used anywhere. And that's what I'll use here now. I'll use that input. I can use it because it's a class variable. It can be used by any method. And it was a string. So what method do I use if I want to read a string? Next line. Perfect. Thank you. And then what do I do? Return student number. And in your method, in your comments, you can just kind of go normal English. You don't have to write student number like a variable. There. Look at the method. The method is independent, has no clue who's going to call it, has no clue of what it is called. It created a local variable student number, prompted you to give it in, read it, and returned it. And that's exactly how methods are written. Independent logical units of code that do a job. Okay, makes sense? So please don't say, oh, here it is called student number. Is that the same student number? No, it is not. Right? You could just call it number here. You could have just called it student ID here. You could have called it anything you like, but this is a local variable. Local variables. Anything inside here are called local variables. The parameter list also is local, though there is nothing. Please do not confuse it with the student number that is sitting in main. Those are main's local variable. There is no relationship. Right? So when as if you're sitting here, you can see this room. You go for your math class in H whatever, you see that room. It's like that. Right? The projector here has no relationship with the projector there. They do the same job, but that projector in K326, projector in H, I forget, 109, 209, 211, something, right? So it's an independent method. You'll say, why don't you just change names and don't confuse us? Because I can't think of any other name. Naming is difficult, right? Correct naming and useful naming is difficult. Why should I bother when it doesn't make any difference? Okay, one done. Now let's go to the second one. Forgot my semicolon here. So I can see a red squiggly right there. If you see some squiggly and you can make sense of the error, do it right away. I had missed my semicolon, so I was seeing a red block here. Okay, second method written. Get the mark now. Let's write the third method. Get student final mark. Let's write our third method. So see, I copy it and then I kind of complete it here so that I don't go wrong. You can go the other way. You can write your methods first and then you can write your calls, whatever you like. Okay, complete it now. It's a private method. All helper methods. These are also called helper methods for your information. What are they doing? They're helping the main method. Right? These are also called helper methods. It's a static method for sure because main needs it. Main is going to call it, so it has to be static. It's returning a mark which we said would be an int. So the return type is int. It is taking a parameter of type string. You have to tell the type so that when you call it, it knows, oh, a string will come to me. It has to know, otherwise how will it do its job? Right? So the method has to know what is coming to me. What is the type of it? What is the name? Now, locally, it's called student number. That's okay. So inside get student final mark, there is a variable. This is a local variable. All parameters are local. There is a local variable. Okay. So now let's do this. We'll kind of copy this, though it doesn't make a lot of sense. There is a lot of change, but anyway. So this method inputs or asks for or takes, whatever you like, accepts. Accepts would be a better word instead of inputs, if you like, because sometimes students get confused with input and whatever makes sense to you, as long as it makes sense to me also. Now, instead of student number, we are asking the student final mark. Is it an apostrophe S or the S apostrophe? And return the student's final mark. It also has a parameter. Students. I think I'm getting the right grammar. This is the apostrophe must come before this, after it. And there is a param here. It takes the student number. So take this param from here, put it here, and this is what? The student number. Why does it take the student number? I'll tell you why it takes it. It doesn't need to. To ask somebody's final mark, you don't necessarily need their student number. But notice what I'm going to do. I'm going to make it a little personal in the sense that it's easy for the student to read. And it becomes all the more better if I have 100 student marks to enter. So if I can see their name, I can enter their mark, their name, their mark. I'm going with number just for the heck of it. Okay, so we can again kind of copy this a little. Oh, what does it doesn't like about input? Oh, oops, okay. So I see a red squiggly and I forgot to do this, though I've said it. So you'll have to do the same thing. It has to be a static variable. That's the only thing you have to kind of remember in an application. Everything is static. And remember, what is a class variable? If you want to keep a note, can be used by all the methods in the class. It's like a constant, but it's not a constant. It's a variable. Right? It's an object. Okay, they're called class objects or class variable. Okay, so I was seeing a problem in input, so I thought, oh, what's going on? Okay, I'm going to kind of pick this up just because the job is almost similar, but of course with a little difference. Okay, so now you're prompting for final mark. And to make it a little more personal, I'm going to use a printf here, and I'm saying, please enter the final mark for student with the number, and I'm going to put a percentage %s here, and I'm going to use the student number here. There. So now it will say, please enter the final mark for student with student number this. Right, there I've used it. That's why I wanted to make it more personal. So if we were asking names, it would say, please enter the final mark for, then I wouldn't say student with student number. I would say, please enter the final mark for Joel, for example, right? Please enter the final mark for Martin, for example. Just to make it more personal. It's like as if I have those marks on a sheet of paper and I'm just searching for it, which I do. Like I've created this. When you come and show me your program, I kind of put your names here, right? Or you've shown me your code. When I'm marking it on Blackboard, I kind of do a find here and I say, oh yeah, this person has shown me their output in class. And that's why I give you marks on it. So it's just like asking a personal question where you know exactly what is being done. So we'll keep this in, we'll create a local variable again. We'll need some local variables again. So create your local variables again. If any, I mean, I only have one. What would you like to call it again? You can just call it final mark here. What will it be? Its type. Its type cannot change because it's the same. It's going in the same box. Just so that to prove to you, I can change names. There is no problem at all. You could have just called this also something else. and it's an int. So what will you be using? Int. And what will you be returning? Final mark. There. Job done. So declare a local variable, prompt for the final mark of the student, input the final mark. And you don't have to say and store it in the variable final mark. You don't have to go that commentative. What I mean, just small normal comments. Prompt for it, input the final mark or accept the final mark. You don't have to tell me next int takes an int and it is being stored in final mark. I'm not looking for explanation. I'm looking for commenting of your code. Okay. And then return the final mark. Job done. Now see the use of this. Why did I take that parameter? I took that parameter so that I could use it in the message. Right? I could use it in the message. Now, one thing that has occurred, not frequently, but I would say maybe 1/5 of the class. You were supposed to use a printf to display the program name, the student number, and the marks. If I say I need to see a printf, I need to see a printf. I'm not looking for printlns or print. And the main purpose of making you use printf was that you use format specifiers. %s for string, %d for integer, %2f, 0.2f for float. And irrespective of whether you have a Mac or not, it's not running on your Mac Mason because I think it was yours. You left a note for me, right? There was a syntax error. There was a syntax error. That's why it's not running. So I'll show you what the error is and it will run. So if you haven't done that, I'll give you the minimum marks to show me the output because the question was printf. So you've done it. Okay, you've done it. I'll give you 25%. But you haven't done it like I wanted. My aim was printf, %s, %d, %.2f. 4 things that I wanted to see. Otherwise, why would I ask you to do it with printf? If I don't want to, that's the main purpose, using format specifiers. It was very clear in the question. Please use printf to display the result using format specifiers. So if you're going to use printlns, or if you're going to use printf, but still use the concatenation operator plus and don't use the format specifiers, you're not doing what I've asked you to do. So if something is asked, it is asked with a purpose. I want you to go and see printf. So here, if I remove this %s and I say plus here, how useful is this printf? It's useless. It's like println. I mean, I haven't used any format specifiers. So what's the sense of using printf? The sense of using printf is you get away with using all these pluses and breaking it up and all that. And wherever you want to fill up something, just put this. Now automatically, so I don't have to break my sentence or break my message anywhere. I can write the complete message at one go, put it in double quotes, and then put comma and fill in the blanks with as many variables as I want. That's the purpose of printf. Writing, breaking, plus, breaking, plus. It's too much work. And when there is a better way of doing something, why wouldn't we do it? Right? So then you will lose marks. Definitely you will lose marks. If the assignment is very clear in what it wants, then you will lose marks. Anyway. So and that's done. I used a printf so that you could see and just revise it with me. I did a next int, I did. My method is done. Get student final mark is done. The only one that remains to be done and is the most important one is now calculate the grade. The display information is easy. I'm just displaying information. Now, how do I calculate the grade? This is something that is kind of new in the sense is more. And now in comments, you can remove, you don't have to kind of write the parameters if you don't want to. Like it's just because I was copying it, I kind of just wrote it. You can just write it without, like you can just say off final mark or whatever. And you don't have to, it just helps me to remember, oh, that's the end of it. Okay, so I know it's a private method. I know it's a static method. And I know that it is returning a grade, which is of type char. And this is the name of the method. So these are just the line comments are just so that I don't mess up my opening closing brackets, which new programmers mess up many times. Because it's just new, right? In our daily lives, we don't say, begin, how are you? End. Begin, where do you live? End. So you don't do it. So you kind of tend to forget the opening and the closing braces. Not all languages need it. Python doesn't need it. So you have to just learn the syntax of the language and follow it. Okay? Okay, now comes the big thing that I want you to think about. This is what I want you to do. So the final mark, though I haven't said it anywhere, though I should, I haven't, prompt for final mark, please enter the final mark for the student with student number this. And if you like, you can say something like this. And I'm going to show you, make it a little better. I'm going to declare two constants, a minimum mark and a final and a maximum mark. So the minimum mark of a student is something, percentage D, and the final is also a percentage D. You'll say, what are you trying to do? All I'm trying to do is I'm trying to make my messages more clear. So I'm saying, please enter the final mark, and I'll tell the final mark. It should lie between 0 and 100, for example. So I'm going to use a variable, a constant called minimum mark. You'll see, where is it? We'll declare it. I'm going to use another constant called maximum mark. In a minute, I'm going to declare it and then see. So notice how printf has come handy. No pluses anywhere. Wherever I wanted to fill in the blanks, it will do it this way. The first percentage D will be replaced by minimum mark, which I don't know what it is. In a minute, we will know. The second percentage D will be replaced by maximum mark. And the third between 0 and 100. You'll say, but where is that information? It's right here. Fill this up and then go up. And where you declared your constants, let's declare some constants. Remember constants, what a constant was? Its value never ever changes in a program. So I need two of them. What's their naming convention? All caps separated by underscore. So as you write code, you make it better. Now my prompt message will say, please enter the final mark for student number this. And it will tell me 0-100. So it's giving me more information. So I know that. But who listens? Who cares? Many of you say, I don't care. IDK, that's what I learned from my kids. I said, what's that? I don't care, IDK, right? So, but we'll have to validate it. Right now, we have not learned validation, but we will learn it. So you'll say, what if the student doesn't give it between 0 and 100? What happens then? We'll talk about it when the time comes. But here I've said, please enter the final mark for, we can remove this, for student number this. The neater, the smaller, but clearer. Okay, so let's save it. So do you see, I've declared two class constants. Now you could have declared those constants locally right here if you liked. You could have declared them right here. But usually constants are constants. Nobody can touch them. And so if you put them globally up there, it doesn't matter. So things that cannot be touched or are not vulnerable, nobody can attack them, can go as constants. And everybody needs them. So this method needs it. I could have declared it right here. But if some other method needs it, then at least they're up there and everybody can see it. Okay. If not, then you can declare it locally also. But constants are usually declared globally, but there is no rule about it. If you only need it inside a method, put it inside the method. Okay. So now let's calculate the grade. Now this is what I want you to do. If the mark is greater than or equal to 90, the grade is A. Okay. If the mark is between 80 to 90, so I'm kind of saying 80 to 90, but of course 90 is already been taken care of, so 80 to 89. Then the grade is B. Okay. if it is between 70 to 79, or you can improve, you can kind of change it a little, whatever you like. So I'll just copy and paste, and I'll do something else just because it's going to take more space and then we won't be able to see it. I'm going to do block commenting inside a method. Nothing stops me. Though the only thing that BlueJ does, it starts putting stars for me and I don't want its help. Okay, so I've written this for you so that you can see it. And this is block commenting so that you know it. You can put a star in front of each one of them. Okay, so 80 to 89 is a B, 70 to 79 is a C. You can go A pluses and all that, but then you won't be able to use a character, okay? So above 90 is an A. I mean, I don't know, you can go 70 to 89 is a B. That way we have to write less of them, but at the end of the day, it doesn't matter. 60 to 69 is a D. And then below 60 is a fail. So this is just the criteria, or you can simply do simple. We can do simple also. Maybe all you want to know, did he pass or fail? Maybe you don't even want to calculate the grade. You just want to say, did he pass the course or did he fail the course? Let's try that too. It's not a big deal, right? So maybe you're not interested in the grade. Maybe you're only interested in, did he pass the course or did he not pass the course? So you can do that too. Do you want to try that too? So we'll write another method for it here. Let's write a private static method that's returning a string, or let me say something. Here, let's try Boolean. The more I show you, the better you will get, okay? Let's return a Boolean. Let's call it pass, because I'm returning yes or no. Boolean is yes or no, so pass or no, right? So I'm calling the method pass. And I'm going to pass what? An int student final mark. So this way, how come my system is so slow today? I type and it takes me here. Suppose if this was your only job, you only wanted to find out if the person had passed or failed the course, you could have only done this. Okay, so what does this method do? This method returns true if the student has passed the course. And what does pass mean? Mark is greater than or equal to 60. Else returns fail. So there is a parameter. What is the parameter? It's called student final mark. The two ints because it wasn't typing and I thought it didn't. Maybe that's all you're interested in, but that's okay. And what does it return? True if the student has passed the course, else false. Here, just out of the blue, and it's good that it came to my head. Now I've shown you a method that is returning a Boolean value. No big deal. It's just normal, right? Okay, what would you do in this method? Think about it. What do you want to do? You want to check if the mark is greater than or equal to 60, pass, else fail, right? Again, I'm not doing any printing here. I'll never do any printing in my methods. So I'm going to say if. Let's write if in its easy form first so that you don't get a shock when I write the gradings, okay? So if the student final mark again, I'm going to use a constant here. I'm going to call it passing mark. Named constants improve clarity, give you flexibility. Changes can be made at one place. So named constants are always better than using magic numbers. 60 may not make sense, but the word passing mark makes sense, right? So if the student gets a mark greater than or equal to passing mark, I'm going to return. You don't have to put opening and closing braces. Usually you don't have to, but again, I always try to say, what if I need to add more in it? So it's just a good habit. Okay, so what do you want to return if the person has passed? You want to return true. True is a Boolean constant predefined in Java. That means true, not with a capital T, T-R-U-E in small. So this is a Boolean constant. It's already defined. True is a Boolean constant. Therefore, notice how the return type was Boolean. Else, what do you want to return? You want to return a false. So there are two Boolean constants already predefined in Java. They are called true and false. So a Boolean variable can only take two values, true, false. Nothing else. And in that spelling, and in that case. Therefore, they've gone blue. Try a capital T. And it won't work. When I compile it, it will say true is not Boolean. It has gone black anyway. So it thinks true is the name of a variable. That's what it thinks. Right? It's a name. It doesn't know that it's a Boolean constant. So what do you want to use? You want to use true with a small t. Okay, so this method returns true if the student has passed the course and returns false otherwise. Oh God. Here. I just wrote this so that you could see it. We'll write the calculate grade in a minute. Let me run something for you first, okay? So let's take this method called pass and let's call it. We haven't called it. We were giving grades to students. So let's do it here. Let's just do it. Check if student passed the course. So you need a Boolean variable. You can call it whatever you like. You can call it status. Remember, when you call it, you don't give the type. When you write its signature, there is where you give the type. So there is a variable called status. Of what type? Boolean type. Make sense? So I created a Boolean status and I called the pass method in it. It will return me a true or a false. For a minute, just let's kind of comment this out and just let's display student information first. To show you it works, because unless you see it working, you don't get that confidence. So I've taken input. I'm saying, oh yeah, it is working, but I haven't shown you anything. Let's write this method. We'll do the grade method afterwards because it's the biggest one. It's the biggest one. So we'll leave it. You can leave it alone here. We haven't called it, so that's fine. It's a box sitting. Nobody is calling for help. Bless you. It returns nothing. Okay, so it took the student number, it took the student mark, and here instead of grade for a minute, I'm going to call the status here. We'll change it to status there also, okay? Oh God, it's slow today. What's wrong with it? Anyway. Okay, so it's a static method, returns nothing. It basically displays information. This method displays student information. Please don't say this display all inputted information. And the spelling of inputted is not a word one, and the spelling of inputted is wrong. Just say this method displays student information. If you were writing a normal comment, say display this, and this, right? So it's taking some params. So let's write those params. It's taking the first param, it's taking another param, it's taking another param. Right? And the three params are this. The student number is a string. The student final mark is an int. And the status is a Boolean. And again, I'm saying this is just getting in the habit of writing comments. A normal commenting won't need the add param at all. But it's just easier to do it this way. You're learning something new, and you are also kind of learning to write methods, plus also trying to write Java doc comments. So, I mean, you're not losing anything. If they were not Java doc comments, I would remove a star from here. Here they become block comments. And instead of saying add param, I'll just say the parameters are. I'll kind of say it in English. You see, so these are reserved add param. If it was not a Java documents, I would say the student number is the name of the number of the student or whatever. Like I would just say it in English. Right? And it just doesn't return anything. Okay, so what would you do? You would kind of make it a little pretty here. So let's make it a little pretty. And again, you can just make it as pretty as you want, as long as it is tidy and correct. The correctness is important, but the tidy matters if you're kind of. And printf by default doesn't have a \n on its own, guys. If you want it, you will have to put it. Okay, so I'm going to kind of, again, write it as a sentence if you want. I can write it in different lines if you want, whatever. It really doesn't matter. But I'm going to use printfs for it, okay? So that I can get you in the habit of thinking. Okay, so what do we want? We want, you can write it here. You can say student number, %s. Don't forget %n for the new line. And the student number. Line number 1. You can start copying it if you like. You can write it as a sentence if you like. I could have made that student number also a string and said %, but it's just a. Now, that's a number, so it will say student number. That's a mark, so that should say an D for an integer. Now comes the big question, what will this student status print out? Okay, and I'll show you and then we'll change it. I'm going to do something for a minute. I'm going to remove the %s. I'm going to use printf as if it was a print line. And I want to show you what it prints. And then you can say, oh, I don't want to see true, false. I want to see pass, fail. Because true, false doesn't make sense to a common man. But pass, fail makes sense to a common man. And when we say common man, we mean you, the student. Okay, so it will print out the student number. %s will print the student number. It will print out the final mark heading. And again, if you want them in the same line and everything, you just have to neaten it up a little. Remember, we did 20s and -20s, all that last time. It will print out the student final mark. %d is used for an integer. And then I didn't do anything here because this was a Boolean variable. And Boolean variables are usually not printed as true and false. You kind of print pass and fail, but I'll show you what it does and then we'll change it. Save this program. Save this program, and if you don't have it, pick it up from Blackboard. It's on Blackboard. Whatever I've done till date is on Blackboard. Okay. So if you've missed something, let's see how it works now. I haven't completed calculate grade. It was a little more difficult to write. Oh, here, instead of grade, please make that change. If you're copying it from Blackboard, we have to pass the status now. There is nothing called grade. Let's see how it works. Hopefully it will compile and do its job. Let's see. We can always make mistakes, right? It's our first go. Let's compile it. Errors, Control K. Where are my errors? Let's see. Oh, passing mark has not been defined. Remember, I used this constant passing mark and didn't define it. So I said we can always make mistakes. Okay, so there is a third constant called, oh, and I forgot something. Final. That's how you say it's a constant. It's a final variable. It's not a variable, it's a constant. But what can I say about it? We keep calling them. So static because main is static, final because we want to make it a constant. And I used passing mark, but I never defined it. That's the error I was getting. I'm not sure about if you are getting other errors, but if you are, let me see and see if I can help out. Oh, I still have an error. Control K, where? Oh, because I said I would return something, it's saying, where is your return? So I'm just going to return, see, anytime you say I'm going to return something, it's saying what? I forgot my return. I'm just returning a space. I have to complete the method, or you can comment it out, whatever you like. So we had started writing it, but I changed my mind. I said, I will show you something simple first, and then we'll write a difficult one. So I went with this method, which was simple, just an if else. Just an if else. Does an if always require an else? No. You could just have said, if student is greater than equal to 60, mark is return true. And then you could have checked, true has come, he has passed, else automatically he has failed. So if does not necessarily need an else. So if without else exists. If with else definitely exists. Okay, now let's run it for once so that we know it compiles and runs. Okay, no errors now. Let's see how it looks. Okay, this program takes the student number, final mark, and assigns a grade to the student. This is wrong right now because we are not assigning a grade. We are just saying pass, fail. Displays the student number, mark, and grade. We'll maybe also add status. We know how to do status also now. Okay, so what's the student number? 1, 2, 3. What is the final mark? I'm going to behave myself and give a mark between 0 and 100. I could give minus 60. I could give A, B, C, but I'm not doing those things. I'm just kind of working as I'm told. 65. Student number is 123, final mark is 65, and the status is 123. You'll say, what's that? What is the status? Where is the status coming from? I know where it is coming from. Copy and paste. That's where it is coming from. Okay. So see how copy and paste is so silly? I tell you, never do it. And I do it. Here, I'm going to show you the status. So let's compile it again. You can always compile it from here also, from this window also. There's a compile button here. Right click, main. So it's not complete, but anyway, 1, 2, 3. And see, I could say ASD and it will work because it's a string. I'm going to give it 65. And it says status is true. What does true mean? Does it mean pass? Usually it does, but that's not what you want to do to your user. What do you want to do to your user? You want to say this, and notice again, if, so easy. If the status is true, then you want to print this. And what do you want to print? You want to print true, pass. You want to print pass, okay? So I'm just going to put a percentage S here just for the heck of it, though I could have just said, I don't even need a printf. I can use a print ln here. I don't even need all this. I can just say status is equal to pass. Else. I'm just showing you, you don't need to put an opening and closing braces if it is a single statement. Some students like it, and I like it too, just because then if I have to add something else, I don't have to worry about it. But then some students say, oh, it always has to be put. There. Now it will say, if the status is true, it will say pass. And remember, in else I didn't put a condition if status is false. That's the only two values, true and false. Why should you repeat unnecessarily the condition again? So don't repeat the condition again. Don't say this again. It's silly. Yes, no. So if I put it, will it create a problem? No. But it tells me that you are still baby. So don't be a baby there, right? If it's not true, it is false. There is no other option. And the short form of this, which us humans like, I can only say simply this. I can say if status. Like you say if raining. You don't say if raining is true. You say if raining. So if you want to check against true, just say if status and it will work. So I've written it as, and this is the equality operator, guys. You haven't seen it before. Oh, no, it's okay. And it's a Boolean variable. We should be good. Okay, let's try it now. Last time, and I'll let you go. Promise. I just want to show you that it looks neat. And of course, we'll come back to this. Okay, so student number A123, marks are 45, and the student has failed. Right, let's run it again. On the same screen, it will run again, but that's okay. Can't do much about it. Student number is QW234. The student had 66 marks, and he has passed. So you learned the simple if-else. You've seen it 2 places today. You've learned a Boolean variable, something you didn't do before. Boolean constants. So we'll write the bigger if and the while next time. Okay. So all this is going back on that page. Thanks for your patience. I'll see you again in an hour. So whatever you've done today is on Blackboard under weekly learning, Tuesday, week 6. So please revise it when you come